The Tokyo International Disaster Relief and Infrastructure Expo fell silent. It was March 2019, and the massive convention center in Odaiba was filled with the world's most advanced engineering display. Seismic dampeners from Switzerland, hurricane-proof panels from the Netherlands, earthquake-resistant frameworks from California. Among the gleaming steel and reinforced concrete exhibits stood a modest booth with bamboo poles lashed together with abaca rope, hand-drawn blueprints pinned to a cordwood, and a small-scale model of a suspension bridge that looked like it belonged in a village museum. Rather than an international engineering conference, the booth belonged to 37-year-old Filipino civil engineer Rafa Santiago, who had traveled from the whole province with a rolling suitcase, a borrowed suit jacket, and a design that his Lolo had taught him when he was 12 years old. Rafa was 5'9", lean from years of fieldwork in remote barangays, with calloused hands and a quiet confidence that came from building bridges that actually worked for people who needed them most. His display showed a bamboo suspension bridge design reinforced with traditional Filipino joinery techniques: no nails, no welding. Just precisely cut interlocking joints and natural fiber bindings that allowed the structure to flex and absorb force rather than resist it rigidly. The model could span 50 meters, support vehicle weight, and cost less than 5% of a comparable steel bridge. In the Philippines, Rafa had already built 17 of these bridges in mountain communities where roads washed out every typhoon season and government budgets never reached. But here, surrounded by million-dollar exhibits from corporations with glossy brochures and animated 3D presentations, his bamboo bridge looked embarrassingly simple. Dr. Hiroshi Tanaka noticed it during his walkthrough. At 61 years old, Hiroshi was one of Japan's most respected seismic engineers, having designed earthquake-resistant buildings across Tokyo and consulted on infrastructure projects in 23 countries. He had 3 doctorate degrees, 40 years of experience, and a reputation for blunt assessments that younger engineers both feared and respected. When he stopped at Rafa's booth, conference staff immediately gathered, sensing either a teaching moment or a public dismantling. Hiroshi studied the bamboo model for 30 seconds without speaking. Then he looked at Rafa. "You are serious with this?" he asked in careful English. Yes, sir," Rafa replied. "This design has been used in the Philippines for generations. I've modernized the engineering calculations, but the core principles are traditional." Hiroshi picked up one of the bamboo poles from the display table, weighing it in his hand. "Bamboo," he said flatly. "You propose to build infrastructure for disaster zones with bamboo?" "Yes, sir. Bamboo has a tensile strength comparable to steel when properly treated and used within its natural flexibility range. The advantage is that it bends under stress rather than breaking." "Yes, I know the theory." Hiroshi interrupted. His tone wasn't angry, but carried the weight of someone who had heard every amateur idea imaginable. "I also know that theory is not reality. Bamboo rots. It attracts insects. It weakens moisture, and most importantly, it cannot provide the rigid structural integrity required for disaster-resistant infrastructure." A small crowd had formed. Several Japanese engineers nodded in agreement. One whispered to a colleague in Japanese, unaware that Rafa had studied the language. Why do they let these developing country proposals waste space? Rafa kept his expression neutral. "With respect, Dr. Tanaka, rigid structures often fail during earthquakes and typhoons because they fight the force. Flexible structures survive because they move with it. Our bridges have survived magnitude 7 earthquakes and category 5 typhoons." Hiroshi's eyebrows raised slightly, not in interest, but in the way a professor regards a student who doesn't yet understand why they're wrong. "Survived in villages, perhaps, with minimal traffic and low engineering standards. But real infrastructure, the kind that saves lives during true disasters, requires materials that have been tested by modern science. Steel, reinforced concrete, carbon fiber composites. He gestured toward the expensive exhibits round them. These are proven. Bamboo is. He paused, choosing his words, primitive. It belongs in history museums, not emergency infrastructure. Someone laughed, not loudly, but enough that Rafa heard it. Hiroshi placed the bamboo pole back on the table. I appreciate traditional knowledge, he said, his tone softer now, almost apologetic. But when lives are at stake, we cannot rely on folklore. We need engineering. He moved on to the next booth, a South Korean company showcasing AI-enhanced structural monitoring systems, leaving Rafa standing alone with his bamboo poles and his Lolo's blueprints. The crowd dispersed. A conference volunteer gave him a sympathetic smile that somehow felt worse than the dismissal. Rafa stood there for a moment, looking at his booth, feeling the familiar weight of being underestimated. He thought about the 17 bridges back home, still standing after Typhoon Haiyan had torn through the region. He thought about the steel bridge the provincial government had built 3 towns over, the expensive, modern one that had twisted like a paperclip and washed away, leaving communities stranded for months. He thought about his Lolo, who had built bamboo houses that swayed in typhoons while concrete buildings cracked and collapsed. A voice beside him spoke in Tagalog. Hindi nila maintindihan hanggang hindi nila makita. They won't understand until they see it. Rafa turned to find an older Filipino woman, perhaps in her 60s, wearing a conference badge identifying her as Dr. Las Reyes, a materials science professor from Updiliman who was presenting on sustainable construction. Materials. She had been watching the exchange. I know that feeling, Anik, she said gently. I've been in rooms like this for 30 years. They think developing nations have nothing to teach them. Should I have explained it differently? Rafa asked, frustration leaking into his voice. Dr. Laz shook her head. You explained it perfectly. The problem isn't your explanation. It's their assumption that sophistication must look expensive. She glanced at the abandoned bamboo model. But here's what I've learned. Eventually, reality has a way of teaching lessons that words cannot. She was right. Though neither of them knew how soon that lesson would come. 6 months later, in September 2019, Super Typhoon Karding formed in the Pacific with sustained winds of 315 kilometers per hour, one of the strongest storms ever recorded. It tracked directly toward the Philippines, and meteorologists predicted catastrophic damage. The province of Rura, on the eastern coast of Luzon, stood directly in its path. Rura was home to 8 of Rafa's 17 bamboo bridges, built over the past 4 years to connect remote mountain barangays to coastal towns. The provincial government had been skeptical, but desperate flash floods regularly destroyed roads, and they couldn't afford to keep rebuilding steel bridges that lasted only until the next big storm. Rafa's bamboo bridges were cheaper, faster to build, and he had guaranteed they would flex rather than break. The government had also built 2 new steel bridges in the same region just 3 years earlier, funded by a World Bank development loan and designed by an international engineering firm. These bridges were modern, impressive structures with reinforced concrete pilings and galvanized steel trusses, local. Officials had proudly inaugurated them with ribbon-cutting ceremonies and speeches about progress and modernity. When Karding made landfall, it was apocalyptic. Winds uprooted century-old trees. Storm surge pushed seawater 15 kilometers inland. Rivers became raging torrents carrying boulders, and entire houses in the mountains. Rainfall measured over 800 millimeters in 24 hours, more than many places seen. A year, the two steel bridges didn't stand a chance. The first one, spanning the Baler River, twisted under the force of debris-choked floodwater. Its rigid steel trusses, designed to be immovably strong, couldn't bend. The force simply kept building until structural joints failed catastrophically. The bridge broke apart in sections, with twisted metal beams stabbing into the riverbank like broken bones. It happened in less than 3 minutes. The second steel bridge lasted slightly longer, almost 8 minutes before its concrete pilings, scoured by debris-filled water moving at 40 kilometers per hour, cracked and gave way. The entire structure tipped sideways and was carried downstream, destroying two houses when it crashed into the riverbank a kilometer away. By morning, both expensive, modern bridges were gone. 12 communities were cut off. Evacuation routes were severed. Emergency services couldn't reach isolated barangays. The death toll began to climb as people trapped in the mountains ran out of food and medicine. But Rafa's bamboo bridges were still standing, all 8 of them. The bamboo bridge over the Heartwarming River had flexed so dramatically during the typhoon that people watching from a distance thought it was being torn apart. The entire deck swayed up and down by nearly 2 meters, the bamboo poles bending like palm trees in wind. But the interlocking joints held. The abaca rope bindings stretched but didn't snap. And when the water receded, the bridge settled back into place, slightly displaced but structurally sound. Vehicles crossed it within hours. The same story repeated at every location. The bridges absorbed forces that would have destroyed rigid structures. They moved, swayed, twisted, and bent and then returned to shape. Engineers would later describe it as structural resilience through designed flexibility, but the villagers described it more simply. Yonga bagong chule, tigas pro boli. Young bamboo, flexible pro metatic. The new bridges were rigid but broke. The bamboo was flexible but strong. Within 48 hours, drone footage and ground photos began circulating online. News crews documented relief trucks crossing bamboo bridges while the remains of steel bridges lay twisted in river. These international engineering forums exploded with analysis threads. Philippine news covered it extensively, with one viral headline reading, "Lolo's wisdom beats World Bank engineering." In Tokyo, Dr. Hiroshi Tanaka was having his morning coffee when a junior colleague showed him the footage on an iPad. Drive. Tanaka, isn't this the Filipino engineer from the expo? The bamboo bridges you said were primitive. Hiroshi watched in silence as the video showed a fully loaded truck crossing a swaying bamboo bridge while the narrator explained that modern steel bridges in the same area had been destroyed. His coffee went cold as he spent the next 3 hours reading engineering reports, studying load calculations, and reviewing drone footage from every angle. By evening, he had drafted an email to the conference organizers requesting Rafa's contact information. By the following morning, he had booked a flight to Manila. 3 weeks later, Hiroshi stood in muddy boots on the banks of the Heartwarming River, staring up at the bamboo bridge that had survived carding. Rafa stood beside him, explaining the joinery techniques and load distribution principles. A small crowd of villagers watched curiously. Word had spread that a famous Japanese engineer had come all the way to Roa to see their bridges. Hiroshi climbed onto the bridge deck, examining joints, testing bamboo poles, taking measurements. He spent 40 minutes inspecting every structural element. Finally, he stood in the center of the span and looked back at Rafa. "I was wrong," he said clearly, in English, but loud enough for everyone to hear. "I dismissed this as primitive because I confused simplicity with inferiority. This is not primitive. This is sophisticated understanding of material properties, force dynamics, and environmental adaptation. This is engineering that serves people instead of impressing. Committees, he bowed a full, formal Japanese bow of deep respect. You tried to teach me at the expo. Hiroshi continued. I did not listen. I let my assumptions about modern superiority blind me to proven traditional knowledge. I apologize not only to you, but to the generations of Filipino engineers and builders whose wisdom I dismissed. Someone in the crowd wiped their eyes. An elderly man, one of the barangay captains, spoke up in Tagalog. Sir, read Bakayong Kumuhay picture kasama ang engineer natin. Can we take a picture with you and our engineer? Hiroshi smiled. Of course. The photo Hiroshi and Rafa standing together on the bamboo bridge, surrounded by smiling villagers, was posted on the barangay's Facebook page and went viral within hours, eventually reaching 280 million views across platforms, comments poured in from round the world. This is what humility looks like. Filipino engineering finally getting there. Respect it deserves. Traditional knowledge isn't backward, modern arrogances. But the real impact happened quietly over the following months. Hiroshi returned to Japan and began incorporating flexible infrastructure design principles into Tokyo's earthquake preparedness programs. He co-authored a research paper with Rafa on biomimetic engineering lessons from Philippine bamboo construction, which was published in the Journal of Structural Engineering and cited over 3,000 times in its first year. The Japanese government invited Rafa to consult on rural bridge design for earthquake-prone regions. Universities in Singapore, Taiwan, and Indonesia invited him to lecture. The World Bank updated its infrastructure guidelines to include traditional material considerations, and most importantly, funding flowed to rural Philippine communities to build more bamboo bridges, creating jobs and connecting isolated areas that had been ignored by expensive modern projects. Rafa didn't get rich or famous. He went back to Bohol, continued building bridges, and trained young engineers in traditional techniques that most universities no longer taught. But he kept the photo with Hiroshi on his office wall, not as a trophy, but as a reminder. The lesson from that Tokyo Expo and that Rora typhoon echoes far beyond engineering. It speaks to the dangerous arrogance of assuming that expensive, modern, and complex must automatically be superior to simple, traditional. And proven, it reminds us that indigenous knowledge systems, whether in construction, agriculture, medicine, or environmental management, often encode centuries of empirical testing that modern science is only beginning to understand. Hiroshi learned that sophistication is not about rigidity or cost. It's about fitness for purpose. A bamboo bridge that bends with typhoon forces and still stands is more sophisticated than a steel bridge that looks impressive but collapses. A traditional technique that solves problems sustainably is more advanced than a modern one that requires constant, expensive repairs. And Rafa learned something too, that the world is slowly, sometimes painfully, beginning to see what Filipino communities have always known, that survival, adaptation, and resilience are not primitive instincts but sophisticated engineering principles. That the knowledge passed down from Lolo to Apo carries wisdom that no amount of degrees can replace. And that sometimes the most advanced solution looks like bamboo poles and abaca, bending but never breaking, standing long after the steel has washed away. When the next generation asks why we trust old ways, show them the bamboo bridges of Rora. Show them how flexibility defeats rigidity, how local knowledge outperforms imported expertise, and how the storms reveal what is truly strong, not what resists, but what adapts.